beta, the question number 4 is that a liquid manometer contains a liquid X, okay, and it is used to measure pressure of a gas supply. And beta, actually I explained this. We did first part was first part of subpart 1 of part A. Then beta, we just had to calculate the pressure due to liquid column of liquid X. Okay, so simply we find the liquid pressure using the formula rho gh. We did that. Then we have to find the pressure of the gas supply. Pressure of the gas supply is atmospheric pressure plus pressure due to the column of the liquid, right? So we added liquid pressure, and the atmospheric pressures. So we calculated the gas pressure, right, beta? Next part B of the same question is the pressure of the gas supply stays constant, right? Pressure does not change. It means the gas supply has the pressure like the same 102,024 pascal, okay, which is greater uh, by 3,024 pascals, which is more than 3,000, which is more uh, 3,024 pascal more than the atmospheric pressure, right? Right or wrong, beta? Beta, I'm just discussing what we have
Right,
done
sir.
in this question, okay? So now, so we can move forward. The pressure of the gas supply stays constant. Describe what happens to the liquid levels. You have to describe what happens to the liquid level, okay? Um, part I, the liquid X is replaced when the liquid X is replaced by the same volume of a liquid of greater density. But if you replace the liquid X here with another liquid which has a greater density. But I explained that point in the last class, if you remember. Beta, we know if the density, liquid pressure depends upon the density, right or wrong?
Right, sir.
So
Yes,
beta,
sir.
greater the density of the liquid at any particular depth, there would be greater pressure, right? Yes or no?
Yes, sir.
Ji beta?
Yes, sir.
Okay, now beta, so the pressure of the gas supply is same. It means pressure difference would also be same, which will be 3024 pascal, right? Now beta, the same pressure, but if we use the liquid with greater density, the same pressure would be caused by the same length of the liquid column, or the length of the liquid column should increase or should it decrease? Liquid is more dense, same pressure. Shabash beta. Shabash beta. Beta, I think you have forgotten I explained that point in the last class.
There will be more pressure
Ji
and the
beta?
levels will be lower. The left
Ji beta
side,
Noor?
the left side will be lower.
Beta Noor, I am unable to understand. Beta, can you speak a bit louder?
Sir, the left side will be lower.
Left side will be
Lower.
okay. You said left side will be higher or lower,
Sir, lower.
and right side.
Higher.
So it means what? The H will increase.
Yes, sir.
No, beta, that's not what I told you. That's not what I told you. Listen again. It means you did not get what I told you in the last class. Look, beta. Listen now. So here we got a container or a tube and identical. Beta, one contains this is liquid and liquid. Here we have liquid A. Here we have liquid B. let's say we got a point here. At this point, let's call this point P. Okay, there is certain pressure. Okay, liquid A exert a certain pressure at point P, right? But there is a certain pressure at point P. Right or wrong? Right or wrong, beta?
Right, sir.
Shabash, beta. Please respond. At least so I know you are getting it or not. Now, beta, in liquid B, we got another point Q. Let's say these 2 points P and Q, they are at the same level or they are at the same depth under the liquid, right? The height or depth of the liquid is same, right, beta? Right?
Yes, sir.
Okay. Now, beta, if I say liquid B is more dense than liquid A, right? Then beta, tell me, will there be same pressure at P and at Q?
No, sir.
Ji beta?
No, sir.
No.
Okay. So where the pressure would be greater? At P or Q?
At more dense liquid.
Yeah, so B is more dense, so where the pressure would be greater?
P.
Beta, B is more dense.
Q.
Yes, in B.
Beta, liquid B is more dense, then how can it be P? It should be Q.
Sir, I'm saying B.
Okay, I'm saying point, na beta, B is a liquid. So point you have to either tell P or Q.
Okay, sir.
Okay, so you said B, I thought you said P because it is like more close to that. Okay, now beta, okay, now beta, if we want the same pressure as at Q, now beta, but in the but in the liquid A, the same pressure at as the pressure at Q. So should we go low or should we go high? Where the pressure would be equal to the pressure at Q? Below this point or above this point P?
Sir, below the point.
Below. So let's say this point, let's say here point R. At point R, the pressure is more likely to be equal at Q, right? Now beta, the same pressure, this is H here, and now beta, the same pressure for that H of the liquid column is this, right? Right or wrong? Or you can call
Yes.
it H dash just to differentiate. Now beta, what actually I'm establishing with this point, beta, that the same amount of pressure is caused if the liquid is more dense, with the H will be small, but if liquid is less dense, the same pressure would be caused by a greater H, or for that H would be greater, depth of the liquid would be greater or at a greater depth. Right or wrong? Right or wrong?
Right, sir.
Now beta, you have to understand this. Now if the liquid X is replaced by another liquid which has a greater density, tell me how this H will change. It will increase or decrease?
Sir, decrease.
It will
Decrease.
decrease. It will shabash beta, it will decrease.
Sir, decrease.
Okay, beta, see, this H is the pressure difference. Okay, and we calculated that what is the pressure difference is 3024. Pressure difference is same, right? Okay, because gas pressure is same, atmospheric pressure is same, so it means pressure difference would be same. Now the same pressure, but the same, now we are using a more dense liquid, so it means the H will decrease. Okay, and beta, if H will decrease, how would that decrease? The level on the right go shabash,
Down.
and left.
Up.
You know, when we started this question, you said the opposite. You said left goes down and right goes up. So then it means the H will increase. That would be the answer when if we replace the liquid with a less dense liquid, right? Anyways, but beta, is that clear? Now can you tell what will happen to the level of the liquid when the liquid X is replaced by the same volume of the liquid of greater density, right? So beta, what will happen to the left level? Left level. जी बेटा शाबाश. Left level. शाबाश बेटा.
Will go up.
Yes, left level. Go up or higher. And right level. जी बेटा. Right level.
Lower.
Lower. And beta H. What happens to H? H decreases. Is that clear or not, beta? जी beta.
Yes, sir. Clear, sir.
Next question, beta. A manometer tube with a slightly smaller area of cross section containing an identical volume of liquid X is used. A manometer tube with a slightly smaller area of cross section containing an identical volume of liquid X is used. Now, identical volume of liquid X is used, but now the tube of the manometer is narrower. It has smaller cross sectional area. Right, beta? So, can anyone tell what will happen? No? Okay. Listen. I hope you'll be able to answer after this. Beta, look. I got two tubes. Okay. One is wider and one is narrower, right? And beta, I poured the same amount of liquid. I poured the same amount of liquid in both. Okay, so beta, this is the
Sir,
level
in the
of the
narrow tube, the level of the liquid will be higher.
Shabash, right? It will be higher. Now, beta, I think if you get this, you should get this as well. Now, beta, if the same volume of the liquid X is poured into into a manometer which has the smaller cross sectional area of the tube, then beta, what will happen? The level of G beta
the liquid will be higher.
on both sides or on one side?
Sir, both.
Shabash. And now beta, tell me, will it change the H height difference?
Uh, yes, sir.
Okay, beta, no. We discussed that liquid pressure does not depend upon the shape of the container, right? Understood? So beta, no matter if the tube is wider or thinner, the same pressure would be caused by the same depth. So H will not change. Getting my point or not?
Got it, sir.
Beta, getting my point or not?
Got it, sir.
So beta, what happens? So then both levels higher and with the same H. Okay, so height difference remains same. Okay, beta. Got it or not?
Got it, sir.
Got it, sir.
Okay, beta. Next, beta, explain how gas molecules exert a force on a solid surface. Beta, you remember we discussed how gases exert pressure?
Yes.
जी बेटा. How do they exert? So beta, gas molecules collide with the solid surface. Okay. When they hit and rebound, their momentum changes, okay, which produces a force on the solid जी बेटा got it or not? जी बेटा.
Got it, sir.
Now beta, next part, the increase in pressure of gas when the volume is in decreased at constant temperature. Can anyone answer this, beta? Can anyone answer this? No one? Okay, beta, let's do this. When जी बेटा, when volume of a gas is decreased, जी बेटा, when volume of a gas is decreased, the number of molecules जी बेटा, the number of molecules per unit volume. जी बेटा, the number of molecules per unit volume. Are you getting my point or not?
Getting it, sir.
Beta, are you getting my point or not?
Yes, sir. Getting it, sir.
So beta, please can you complete this sentence? When the volume of a gas is decreased, the number of molecules per unit volume.
So it increases.
Shabash. Number of molecules per unit volume increases. Okay. And beta, so the number of collisions. So the number of collisions
Increase.
per second increases, hence pressure increases. जी बेटा, is that clear to everyone?
Sir.
Should we move to the next question? Beta, a cylinder of volume 5.0 times 10 to the power 3 cubic centimeter contains air at a pressure of 8.0 times 10 to the power 5 Pascal. Now beta, see this first line, what does it tell? Can someone elaborate beta what this question is telling?
Sir, the volume one is 5 into 10 power 3 and the pressure one is 8 into 10 power 5.
Okay, very
12.
good. Now beta, yes, shabash.
V2 by
Beta,
T1,
so
V1 is equals to V2.
yes, beta. But actually, what you actually few things conceptual, beta. Look, cylinder of a volume. You are given basically the volume of the cylinder, right? A cylinder of volume is volume 5.0 times 10 to the power 3 cubic centimeter. It means we are given the volume of the cylinder, right? Now it contains air, and we know that like air, like gases, they do not have any fixed volume. They take they fill the whole container they are in, right? So it means if the air is in a cylinder whose volume is 5.0 times 10 to the power 3 cubic centimeter, actually we know that the volume of the air would also be 5.0 times 10 to the power 3 cubic centimeter. Getting my point or not? Do beta? Getting my point or not?
Yes, sir. Getting it, sir.
Okay, beta. Beta, I think I'm afraid this is as far as we can go today, as the time is up. So